So, what does cloud computing mean to you? Um, can anyone tell me what you think cloud computing means in a short sentence? What do you think when you see cloud computing?
Actually kind of rental space on someone else's server.
Exactly. So it's basically an on-demand delivery where you can basically rent a specific type of service. It could be a database, storage, application, and so on. So back in the day, cloud computing was not a thing. Most enterprises, they had what we call on-premise services. So they would like have a room like this and buy a bunch of rack and buy hardware like routers, servers, switches, and install everything themselves. So they will have like an entire IT staff to manage that. So right now, um, basically, cloud computing help you to stop thinking about your IT infrastructure as a hardware, but instead as a software. It's like everything is being provided by a vendor, and then you just pay. It's like a subscription that you're paying every month, but it's giving you the same power. So like I said earlier, back in the day, the hardware required space, staff, cooling, physical security, guard. You need to install CCTV cameras, etc. You need to do everything yourself. And that's what we call on-premise infrastructure. So now is we're gonna see very soon that the different type of services from the cloud, it's like you have been infrastructure as a service. So the software solution, it's very flexible. It can change more quickly, easily, faster, more cost effective, and it eliminates different heavy lifting tasks because you can imagine building your own IT infrastructure yourself would require a lot of purchase order, configuration, implementation, unboxing everything, and doing everything yourself. And also, you're gonna see later on that it's gonna be more cost effective because with the cloud computing system, you can basically grow, increase the capacity of your system as the company grow instead of buying everything at once. So these are the three main type of service model. You have infrastructure as a service, platform as a service, and software as a service. So infrastructure as a service is basically the building block for cloud IT and typically provide you with access to networking features like computer, data storage, etc. So it's like basically having the servers and the operating system. That's IIS. Platform as a service and then software as a service. Basically, for software as a service is tool like, for example, if you use Facebook.com, gmail.com, or Canva.com, or any type of web-based software that you see, you can log in on the browser and you can use it out of the box is a software as a service because you can use the software directly from the browser without paying attention about whatever infrastructure is providing this is supporting this software. Because when you see the software in the web browser, it is actually a set of code source built on top of a database that is being hosted by a server, and there's an application running on this server. And there is a real hardware server that is hosting this software that you can see that you're using on your web browser. So all of this is transparent to you. You're just using the software as a service. Well, you can pay a subscription to just use the software. For example, if you're a creative, you can see that, for example, now you cannot buy Adobe Photoshop or Adobe um, uh, any type of Adobe software on the city right now. Everything is from the cloud. So compared to infrastructure as a service, you can actually rent the actual server. Like if you want, let's say, 3 servers that are running Windows servers, and then you are going to install your application on it, you can use infrastructure as a server. You can say, oh, give me 5 Linux servers, give me 5 Windows servers, and then they're gonna provide you the the hardware, but you're not going to see it, but you're gonna have access to the operating system itself. And then you have the responsibility to configure it, secure it, install the application that you want. But here it's the opposite. They give you everything until in the software. You're just using the software. And then you have platform as a service, which is a service in this category. It reduces the need for you to manage the underlying infrastructure, and it enables you to focus on the deployment and management of your application. So platform as a service is really used by people that are software developers. So basically, it's gonna be you know what an IDE is? Anyone know what is an IDE? So an IDE is like the tool that you use to build a software. The software engineer is the one that code the application on your smartphone when you see, I don't know, Snapchat, Facebook, and all that. So before it become an application, the software engineer sit and write all the code to build this app. So the software that they use to code the app, it's called an IDE. And the platform as a service is this engine, this space where the software engineer can use it to code. So they are building themselves the application. Here they are building the application. Here they're giving you the application to use, to just use. Here they are giving you the underlying infrastructure, and then you're gonna build your application on top of it. You got it? All three. This is all of the different type of service model. Now, deployment model, which is a different concept. Deployment model, I wish I could write straight on the screen. We have cloud, hybrid, and on-premise. I already explained what on-premise means. So that's what we call now private cloud, because what happened is that some enterprise, they are dealing with so much sensitive data and PII, what we call protected information and identifiable information. They cannot go fully or partially on the cloud, because the thing is, with the cloud, it's beautiful. Yes, we agree on that, and it's so nice and very easy, but it is something that you don't have a 100% control on. So what they do, they decide to keep certain data on site, on premise, because this type of data, they cannot manage the risk of having them being on the internet if there is a data breach. So there is on-premise, cloud. Some people, they go fully cloud. So the business can start as a cloud native, like from the get-go. Everything is on the cloud. They have like 100% of their workforce, which are fully remote. And then everything is on the cloud. But some enterprises or organizations, they can say, oh, let me go, let me take some of both world. So I'm gonna do a mix of both. So they go in a hybrid mode. So they will have both the private model and the cloud model. So basically what they do, for some application, they're gonna use cloud services, and for some other application, they use on-premise, on-site application. And then they make sure these two are interconnected, and then they can talk to each other. So basically, the cloud is a mirror of whatever we used to do on premise. So, or whatever the type of service we used to do on premise, you will have it in the cloud as well. So, for example, now we're talking about the cloud services from AWS. It's You're gonna have firewall. You guys know what firewall and those stuff are? Okay. Access control list, administrators. In AWS, it's gonna be security group, network ACL, and IAM. IAM stands for identity and access management. They're gonna have on the cloud, it's like a portal. You're gonna log in to the website, and then you're gonna have all these services. If you're on the premise, you're gonna have like a router and a switch. In AWS, it's called Elastic Load Balancing, Amazon VPC. So, and on premise, you're gonna have these network attached storage or storage area network, which is like a box that has a big hard drive in it, but it's connected to the network. So everyone on the network can put file, save file, and retrieve file. And then, well, in Amazon, you're gonna have bucket like Amazon S3, Amazon RDS for remote desktop services, Amazon EBS for data storage. So for anything you would do on premise, there's a way for you to do it on the cloud and provide the exact same service. Question? So the cloud computing is the on-demand delivery. So the key takeaways are cloud computing enables you to think and use your infrastructure as a software. There are three cloud services model, IaaS, PaaS, and SaaS. And there are three cloud model, hybrid, on-premise, and private cloud. So what happened is that before, when let's say you were going to open a business, and then after you buy everything, offices, chair, etc., you're gonna buy hardware for your IT. So you would create like a purchase order and buy everything on the spot. So that's what we call CapEx. It's considered as a capital expenditure. Because what happened is that you buy switches, you buy a location, you buy air conditioner, ACs, you buy UPSs in case there is an electricity interruption. You buy CCTV cameras, you buy switches, you buy routers, everything at once, all at once, and then that's a very huge amount of money that you need to spend right on the spot. So we call that CapEx. From a budgeting perspective, you're gonna be spending that all in 1 month. Now, instead, because cloud computing is different, instead of CapEx now, from a financial perspective, it's gonna be OpEx. It's an operational expenditure. Why? Because now you're spending gradually. So what happened, especially for example, if you're a startup and you don't necessarily know how many users or customers you're going to have, so you will probably go for the cloud route because what the cloud allows you is that you can grow with your business by every time there is more demand, then you can just request more power or more services from the cloud. So basically, instead of spending a bunch of money right on the spot, you're gonna spend operational. So there's a different line in the budget when it's operational. So basically, it's gonna be like, for example, a monthly services. So this month it would start with 400, and then next month it could be 600. It's a monthly services now that you're paying instead of spending 15K right now. But next month it could be 200. If it's Thanksgiving, it could be 2,000 because, for example, an Amazon, I'm sorry, a business like Amazon, for example, when it's holidays, people are buying more because they need to give gift. So the traffic on the website is gonna increase. So what happened right on the spot because it's on the cloud, they're gonna increase the number of servers, the number of service from the cloud that they need to respond to the demand. So your cost for this month is gonna be higher if you are buying services from Amazon. Let's say you are a third party vendor, let's say Target, and you're using Amazon services, and everybody is going on the Target website to buy. So Target is gonna increase the amount of servers they need. And because this cloud computing thing is like on the spot automatic, you just click on a button, you request a new server, and boom, your server is ready. It can take like a few minutes. Compare if you needed to install a new server on site, you need to order it, they need to ship it to you. You need to wait for the server to be delivered. Then you need to unbox the server, install it, install the operating system, configure it, and secure it. Right now, Amazon, Azure, Microsoft, they have like bunch of data centers all over the world that are ready to spin up a server for you, and you just pay as you grow. So for Thanksgiving month, your bill is going to increase. And that's why right now we talk about capital expenses versus operating expense. Basically, this is what I was saying. By using cloud computing, you can achieve a lower variable cost, and then you can get on your own because usage of from hundreds of thousands of customers is aggregated in the cloud. Providers such as AWS can achieve higher economies of scale, which translate into lower pay as you go prices. Again, what I was saying, when you start a business, you can guess the best. Like you can only estimate, oh, okay, let me start with one or two servers. It can only be an estimation. You don't know how your customers or the market is going to receive whatever the service or product you're going to give. So you're going to do your best judgment and buy a certain amount of servers. So you do the it's gonna be either you underestimated or you overestimated. So versus in the cloud, you can scale on demand and provide more and more computing power as customers are requesting it if you're on the cloud. Where versus if you're on premise, then if there is too much demand, your servers are going to be overheating. And then what happened? Oh, we need to buy more servers. And this is a whole process from an administrative perspective. So that's what cloud provides. It's the agility. So to spin a new server or to buy, for example, right now at the right instant, if your phone doesn't have enough storage and you're on vacation and you want to do you want to take more pictures and more videos, right at the moment you see that, you can instantly buy more iCloud storage from Apple, and then boom, magically you have more storage. So it's just literally at the click of a button, you can spin a new server and a new storage on the cloud. So it can take like a few minutes, maximum a few hours, and then you're good to go. Versus the whole process it requires to buy the server in terms of purchasing, going through approval, etc. So um it's it is a pretty it's a little bit tricky because some people right now are complaining about cloud. The people are saying it's not what they think it was because it can get pretty expensive. So I've seen on LinkedIn people that go all the way back on premise, like they're leaving completely the cloud. So it's an investment. Basically, instead of wanting, it depends on the business because you need to do what we call a cost analysis, a cost benefit analysis to see what are the cons and the pros of going to the cloud, or do you go to an hybrid model, or do you stay on premise? Because if you're running your own data centers, um, it's a different realm. Like it's a different type of scenario, different type of situation. You need to provide your own cooling, provide your own data center technician. And a data center, it's like a 24/7 operation because your business has have this capacity to maintain it. Because when you're in the cloud, all you have to worry about is selling, doing what you're best at, which is selling or providing whatever the service or product that you have. So basically, when you're in the cloud, you can focus on really what you're good at and don't not worry about all the technical details. And because whenever there is an issue, all you have to do is pick up your phone and call and say, hey, what's going on? Why is the service down? Because there's something called SLA. You know what this is, right?
Service level agreement.
Yes. And basically, if it's 99.999%, they can give you back money. They can pay you if they don't respect the service downtime that they say they can have. So basically, that's the benefit and the beauty of the cloud because everything is provided by you, which is the third party. And you need to ensure that my infrastructure is working very well. Because maintaining your own data centers can be challenging, especially also you need to find the right skill set, technician that have the right skill set to hire also. And human resources is not always fun. You can go global in minutes. So if you are providing a specific product or service that is scalable, maybe you started in the US and then it's working well, and then all of a sudden you want to provide the same service. Let's say it's an app, and then you want to provide the same service in Japan or Russia or in Europe. Well, you can select in the cloud which region where you want the service to be, and then it's gonna be more effective because what happened, there's something called latency. So if you're in Africa, let's say you're in the US, and then you're posting, you're scrolling, and tomorrow or next week you go to Africa and you keep posting and scrolling on Facebook. Do you know when you post or in scroll on Facebook, you may see there is nothing different and everything is similar. But did you know when you were in the US versus when you travel to Africa, the Facebook you're using is not being responded by the same servers. Because otherwise, it was going to be too slow. So if you're in America and then you travel all the way to another continent, which is Africa, and the servers are in the US, you're here, and you have your smartphone with you, the data, when you pull the Facebook feed and it retrieves the data from the server, there is a specific server in the US region that is providing you the data when you request it. Now, can you imagine you being here now in Africa, and then every time you need to go to Facebook, it's the same server that is responding to you? The amount of latency that you will get. So what they do, Facebook or all these companies, they have data centers all over the world, and what they did, they duplicated the same data. When you upload a photo, this photo, that's why they say when you post something on the internet, it doesn't go away, never. It's because, so, I mean, we don't know if we delete a picture, if it should be like that. When you delete a picture, it should be deleted on all the instance on all the servers. So basically, when you upload something, it's being replicated on all the servers, and it's available. That's what we call a cache memory. So if you're in Africa, your region or your location changed, and it says you're in Africa, and it's going to request a copy of that data that you requested that is in the server in Africa, not over there. So that way, when you pull the request, you do the request, the data that is being provided to you is from the server located in the data center region in Africa. So if you're going global, then you can basically say, hey, um, let me select, I'm gonna say AWS, create a server for me in this region. And also, you are in compliance, you know, you may have to create this server in this specific location. Why? Why?
Uh, well, does it have to do with like different laws and stuff?
Laws, yes. So for data privacy, Canada may say, I will not allow you to provide the service if your servers are not in my country because I'm protecting privacies for my citizens. In Europe, they have GDPR, the General Data Protection for. So you may have to, if the customers are in Europe, then you must have your servers in Europe because the laws will say my citizen data need to stay in my countries. So you may have for just for compliance reason. These are the key takeaways from everything we just said. We talked about trade capital expenses versus variable expenses, massive economy of scales. Stop guessing the capacity because you don't have to worry about that anymore. Increase speed and agility. You can stop spending money on running and maintaining your own data centers, and you can go global in minutes. All right? Question? So basically, what are web services? Amazon called his cloud computing Amazon Web Services. A web service is any piece of software that makes itself available over the internet, and you can basically use it. So it's not tied to any one operating system or programming language. It's self-describing via an interface definition. It's called basically an API. An API is an application program interface where it's basically interconnecting two services. So it's like a middleware where two different services can exchange the data between each other. So AWS is a secure cloud platform that offers different type of product and services. Um, it offers flexibility. You pay only for the service that you need as long as you need them. And it's like a building block because AWS can do so much thing that you can start very small, and as long as you go, keep adding services that you need. There's so much services that it can be overwhelming. These are all the categories of AWS services that you can have. And we will have to go through all of them during this class. AWS fall under different categories of each categories contains one or more services that you can select the services that you want from these different categories to build your own solution. Because there are people that literally build their entire application stack from and on AWS. It's like what we call a cloud native application. So for example, let's say you're building a database application and your customer might be sending data to your Amazon, what we call EC2, Elastic Compute Cloud, which is a service in the computing category because Amazon has multiple services. So these EC2 servers, they batch the data in 1 minute increment and add an object per customer to Amazon S3, which is the storage bucket services. So you can use an non-relational database like Amazon DynamoDB, which is another service, to power your application, for example. And you can build an index so that you can find all the objects for a given customer that were collected over a certain period. And you might also decide to run specific services inside of Amazon VPC, which is another service in the networking category. So the purpose of this is quite simple example to illustrate that you can select different type of servicing from different categories, and you can use them together to build one single solution. In this case, this is a database application. And obviously, the solution that you're building can be as complex as possible. So which services are you going to take a bit? So obviously it depends on the type of business that you have or the type of technology requirement that your enterprise needs. So you can have an Amazon EC2, which is when you want to complete control over your AWS computing resources. There is AWS Lambda, which is when you want to run your code and not manage or provision your own servers. We have AWS Elastic Beanstalk. It's when you want a service that deploys, manage, and scale your web application. Amazon Lightsail. It's when you need a lightweight cloud platform for a simple web application. AWS Batch. It's when you need to run hundreds of thousands of batch workloads. AWS Outpost is when you want to run AWS infrastructure in your on-premise data center, etc. And there is also Elastic Kubernetes services, container services, VMware Cloud on AWS. This is when you want to have an on-premise server virtualized platform that you want to migrate to AWS. Let's say you have a specific virtual machine on-premise, and then you want to migrate it into AWS. VMware Cloud on AWS will help you do that. So there's a lot of services and products from AWS. So the array of AWS services can be quite intimidating, if to say the least. So as you start your journey into the cloud, you'll have time to learn about these. And this course will focus on some of the most common services in the following categories: compute, storage, database, networking, and content delivery. Security, cybersecurity, identity, what we call IAM, identity access management, compliance management and governance, and AWS cost management. Because cost management is something for us, like we are tech people and we hate, but I'm sorry, let me talk for myself. I hate numbers. This is financing, accounting. Oh my God, this is not my cup of tea. So we we don't like numbers. We like to break things and make things work. But when you're talking about cloud, this is a piece that you really need to ensure that you really pay attention to and you need to manage very well, because now it's not something that you bought once and it's done. This is an ongoing cost. So you need to be very careful, for example, about if you don't need a server anymore, turn it off, shut it down. If you were using a specific type of service for a specific period and you don't need it anymore, delete it. Because how the cloud work is, as long as the service is up and running, you're paying for it. Okay? So cost management now, it's becoming extremely important when you have a cloud services, even as a technician, that because this is something that now you need to always have in the back of your mind. So AWS cost management services, AWS budget, AWS cost explorer, it's something that you have to care about. So these are the way you can interact with AWS. We have AWS Management Console, which is a easy to use graphical interface. You have the command line interface for the more geeky guys or women. You can do stuff also via command line. You can access their services by typing command or script. You know what a script is like a piece of software that you can write. And you can access the service by software development kits as well. So basically, AWS provide packages that enable accessing AWS in a variety of popular programming languages. This make it easy to use AWS in your existing application, and it also enable you to create applications that deploy and monitor complex system entirely through code. So you can use programming language such as Java, Python, and others. All right. So we we mentioned that AWS is a secure platform that offers a broad set of global cloud-based products called services that are designed to work together. There is a bunch of services provided by AWS. There are many categories of AWS services, and each category has many services that you can choose from. And then you can choose a service based on your business goal and technology requirement. And then there are three ways to interact with AWS services. So is it 7 or 7:15 class time? 7:30? I think
Yes.
7:30. I think it's 7:30. Let's talk about CAF, the Cloud Adoption Framework. So basically, IT wants, so not IT business is all about people process, and technology. It's like three pillar of anything you do, because if you forget about only one of them, it will go very bad. The process will break, the solution you're trying to deliver will fail miserably, it's gonna be a mess. So whenever you're doing any type of migration, technology implementation, or infrastructure change, you need to consider the process as is and the process to be. The people, which is sometimes a component that we tend to neglect because, yeah, the people, they just have to get used to it. No, the people are the main, is very important because they are the one that are going to use the piece of technology. And actually, you need to do what we call a user acceptance test, which is part of a project management process where you get to understand the feedback from the user and the technology. So these three components, um, you really need to take care of them. So basically, AWS adoption framework is the process of adopting the cloud mindset with AWS. So it provides guidance and best practice to help build a cloud-based company or to move to the cloud. And it's literally a comprehensive approach on cloud computing across the organization and throughout the IT life cycle. And so this framework is established around six perspectives, which are these: the business, people, governance, the platform, security, and operation. So in a, in a given organization, each organization's cloud adoption journey is gonna be unique. So there is not a like a one size fit all. It's really, that's why when a cloud architect will come and speak to you from the business, it's gonna be a lot of meeting to understand your current situation, what are the um, compatibility requirement before you migrate to the cloud. It's a whole process. So that's why the cloud adoption framework, it provides guidance and best practice to help organization identify gaps in skills and processes. So it helped the organization to build a comprehensive approach to cloud computing and to make sure that there is a successful cloud adoption. So in general, the business people in governance perspective focus on the business capabilities, while the platform security and operation perspectives focus on the technical capabilities. So the stakeholders, the business process owners, from the different type of business unit, for example, the finance manager, the business owner, the business manager, the purchasing manager, everyone that we call BPO, the business process owners, can use the AWS CAF to create a strong business case where they gonna mention how the cloud adoption is going to be and how they need to prioritize cloud adoption initiative. So these stakeholders, they should ensure that in organization business strategies and goals really align with its strategies and goals. Because so sometimes us IT technician or IT engineer, we really think that we are the all in everything because we know that the business cannot function without us. And well, we think we are the supermans. And so the thing is, we need to be careful about that and always remind ourselves that IT is not working for IT. IT is working for the business. We are just a support function. And because we are extremely important, sometimes we may think that um, we are we are we are the entire goal. We are just actually we are sometimes considered as a cost center. So we don't bring money into the business. We just make sure that everything runs fine. So whatever IT is doing, it needs to make sure that it aligns with the business goal. Otherwise, we are not needed because at the end of the day, we don't do whatever we want or whatever we think it's the best to do. We need to make sure that what we call the BPOs, the business process owners, basically all the stakeholders of the organization, they explain to us what is needed, and we have to align our implementation strategies to theirs. So the stakeholders can use the AWS CAF to evaluate organizational structure and roles and new skills and process requirement and identify the gap. So performing an analysis of needs and gap can help prioritize training, staffing, and organizational changes to build an agile organization. So basically, it's very important to do this gap analysis to understand how the process is right now and the process to be, how it's going to be, and do this gap analysis to understand, okay, in our current process, this is how we used to do from an operational perspective. And so when we go to the cloud, how is it going to be in? Maybe do we need to hire, and because the new process may require new stuff, whether it's new human resources, new hardware, maybe it needs the layout of the organization need to change. What's going to be the difference? So this gap, we need to address it to make sure that at the new process, make training, obviously, it's gonna be, you're gonna have to need a lot of training because people that were here maybe in the company for 10, 20 years, they're not used to do things online or in the cloud. Now they need to be trained in not only on the new system, but also on the new process. Governance. So, for example, the CIO, the Chief Information Officer, program manager, the enterprise architect, and the business analyst, they all can use the AWS CAF to focus on the skills and process that are needed to align IT strategy and goals with business strategy and goals. This focus help the organization maximize the business value of its IT investment. I already spoke about that earlier. So now the last one, no, that's not the last one. Platform, which include computing, networking, storage, database, and system. So different business process owners, they can use the AWS CAF as well to include the principles and pattern for implementing new solution on the cloud and for migrating on-premise workload to the cloud. Security. Now, everything like identity and access management, detective control, infrastructure security, data protection, incident response. All of these, they there is a module in the cloud system that needs to be taken into consideration as well when you're migrating to the cloud. It's especially things like identity and access management is sometimes a headache because when people migrate to the cloud and now they have either the wrong permission, too much permission, or not enough permission. So this can lead to fraud. So and also people can do stuff they are not supposed to do. And this is a very dangerous situation because now you can have someone that have access to stuff they shouldn't have access to. Incident response, basically how you're going to respond to an incident and do we know, do we have a procedure on who need to do what and when? So um, in this case, it helped the stakeholders to define the current operating procedure. It also helped them identify the process changes and training that are needed to implement successful cloud adoption. So from an operational perspective, it's almost the basic common IT operation stuff like service monitoring. Do we monitor the network and making sure that it is at the performance that we need? Inventory management. Do we know exactly what do we have, what system are running, and what are the impact they can have if they are down? Release management and change management. This is a very big one because in terms of change management, sometimes it can go wrong because someone forgot to focus on the communication part of it. If you're doing a change management, you need to make sure that you involve all the stakeholders in all the business units that are going to be impacted. So, for example, let's say that you need to make a change, a very simple change, a switch, like the switch migration. They are upgrading from a specific model to the newer model, or they are keeping the same switch, but they are upgrading the firmware on the switch. So, step one, what will happen? How would you manage a change like that? You need to think about the consequences, the step to upgrade the firmware or to put the new one. What is the first thing that will happen when you do something like that?
The switch will go down,
Huh?
the switch will turn off or
The switch will turn off, yes, we know that, but the switch turning off will do what?
prevent users from accessing stuff.
The whole network will go down, which means users won't be able to access their system, shared drive, application. So what needs to happen?
Put them on the other switch, temporary switch. Or
Inform all the impacted users, because I say all the impacted users because it could be one floor, it could be the entire organization, but it could be just a subsection. Now, inform everyone from this time to this time, the range, usually we do that on the weekend or after hours. So every one needs to be informed that, hey, if you wanted to work late or overtime this day, it won't be possible because you need to communicate that on Thursday the night all system will shut down at 5, and there will, whatever the service will be impacted, there will be no access to the accounting system, or the internet will go down until this day. So you know that everyone will go back to work tomorrow morning at 8, so you need to have everything ready by then. So what if something goes wrong? What do you need to have?
Backup plan.
Thank you. So you need to have a rollback plan. So basically, let's say it is a firmware that you are upgrading, you need to back up the current settings in firmware on a stick, USB stick, or you need to have two. If you're changing an entire switch, you need to have a spare out switch, or being able to go back to the old switch. So just in case after you've done everything and it's still not working, you need to go back to the previous state. So always do backup of the current settings and configuration before you move to the new one. So this is all inside just change management. Just change management, we have all of it. So inside of the change management, we have the communication plane, we have the rollback plane, and then the implementation plane. So usually it's best practice to have, because not everyone has a great memory. So it's better, even though you have a great memory, to have a checklist. So you know that you've done this, step 1, step 3, even if you can have like a step-by-step procedure printed, so you can be sure you've done everything based on the book. So you have a checklist in place. Well, if you've been doing this for 10 years, maybe not, but you have a checklist, and then to make sure, so everyone knows what's going to be done. Everyone knows what users will be impacted. The claim is approved by management. They know about it. And then you do this after hours to to have minimum impact on the business operation. Because people not working will complain, and complaining can say, hey, I'm not making money, the business is not making money, which is not necessarily true, but hey, users like to complain about IT. And this is a great way to not to work, because they say, oh no, it's not working, so let me have some fun. They don't have to work. So release management is like when you're releasing a new version of maybe firmware or operating system. Business continuity and disaster recovery, which is extremely important in terms of having a plan to go if the cloud service is done. For example, well, what are we going to do if AWS goes down? What do we do? We have what we call a DRP plan, a disaster recovery plan, a business continuity plan that will, so these two are similar, but they are quite different. The disaster recovery plan focuses more on the technical side of things, the aspect of restoring the backup and stuff. But the business continuity plan focuses more on the operational, making sure the business keep running, and we decrease the amount of money that we are losing whenever the impact happened or whatever what it was. So for a business continuity, we can say, hey, maybe we're going to go back to paper. We need to keep selling. So we are going to do invoices on paper, and then after that, when the service go back, reconciliate everything. Because the business continuity plan is how we can keep operation, although our main application is down. So what have we seen so far? Cloud adoption is not something automatic. It's for most organization, it requires a lot of meetings and planning, and it needs to be very thoughtful and a deliberate strategy and alignment across the whole organization. So if you're moving to the cloud, it's probably going to impact multiple business units. So everybody needs to be onboarded and be involved on what will be the changes, what are the impact for the organization, what will be the new process. So it can be very painful actually, especially if you were completely on premise. Now, it's, some people have what they call um, legacy application. These applications that were built in the 90s on COBOL or whatever system it was, like that they wrote in C sharp or in C, these legacy applications, they most of the time are not compatible with the new operating system like Windows 11, Windows 10. So these were written by our old ancestors back in the 80s. So sometimes moving this application on the cloud will probably require, for example, to create containers or enclave for virtual machine where you create a space for them, just for them to live. It's like you have a kid that's have a special need and either they sick, and then you need to build a special bedroom for them with maybe handicap wheel or specific way the room needs to be, and then you put it there. So the application can live there freely, and then you create an API to communicate with it. So these applications, when you're moving them to the cloud, they need a lot of TLC, take love and care. So it can be quite difficult process. So that's why you'll have cloud architect meeting with you, speaking with you, and to understand what you really need and how they can prepare the cloud environment for you. So the CAF is a very important framework and documentation that you need to review because it can help you create and help the organization develop efficient and effective plan for the cloud adoption. And then we've just seen earlier that this can help the business as a guideline and review all the 6 areas of focus. They call them perspective. So each of the 6 areas, they need to be taken into consideration very carefully. So the people, technology, the process, the plans, etc. And then lastly, it is the responsibility of the key stakeholders to make sure that everything goes well. Mhm.
Now regarding that, what's the last day today, last date from the course that are being charged?
It is mentioned in the introduction in the Canva platform. Please check it out. I don't have it in the top of my head, but it's mentioned.
It is actually to go on AWS platform, which are provided some kind of EML offers for us. Because